All right. Okay. So here we have some exam questions which I would like us to solve. Our first question here says find the general formula for the nth term. So we're given this sequence here. We have negative 11, negative 6, and negative 1. So the sum around it didn't specify the type of sequence that we have. So first we have to determine, before using any formula, we have to determine whether it's a sequence, maybe an arithmetic sequence or a geometric sequence or any other type of sequence. But then in order to determine that, we have to observe the relationship between the consecutive terms, meaning we have to check the relationship between negative 11 and minus 6, and again minus 6 and minus 1. So what we are given, okay, so between minus 11 and minus 6, what can you deduce from the two numbers? Because it's possible that okay, let me do like this. I want to show you this first. Okay, so if we have a sequence like 2, 4, 6, 8. Okay, so this sequence that we have, you can see that the difference, okay, the relationship between 2 and 4 is that we have to add 2 to get 4, and between 4 and 6 we have to also add 2. Between 6 and 8 you also have to add 2. So if your sequence is like this, we call this sequence an arithmetic sequence, because the between each consecutive terms we have to add 2. In other words, we have to add a constant number, like the difference between the consecutive numbers is consistent, which is 2 in all cases, as you can see here. So we call this sequence an arithmetic sequence. This one is an arithmetic. But then there are cases where maybe you will get a sequence like this. Maybe we have 3, then we have 6, we have 12, we have 24. Okay, the sequence between 3 and 6, we see that the difference, we can say the difference is plus 3, but between 6 and 12, now the difference is plus 6. The moment you realize that the difference is not consistent, now you know that this sequence is not an arithmetic sequence. So you just remove the possibility from your head. Okay, and if we can continue, we can see that between 12 and 24 we have plus 12 as a difference. So this one is not an arithmetic sequence. But then look at this. Between 3 and 6, you see that from 3 to 6 you multiply by 2. Between 6 and 12 you also multiply by 2. You say 6 by 2, you get 12. Also between 12 and 24 you multiply by 2. 12 by 2, also you get 24. So this one is a geometric sequence. So that's how you can tell whether a sequence is a geometric one or it's an arithmetic sequence. You have to test first. So in our case here we have negative 11 and minus 6, the first consecutive terms. Okay, what I will do here, I will first check whether it's an arithmetic sequence or not. So I will say minus 6, which is our second term, minus 6 minus negative 11. Okay, minus 6 minus negative 11 we get 5. So the difference between negative 11 and negative 6 is positive 5. Actually, the difference between negative 6 and negative 11, yeah, is 5. Because when you say negative 11 plus this 5, you get minus 6. And again, now we test between negative 6 and negative 1. So we're saying negative 1 minus negative 6. We are also, this is the same as negative 1 plus 6. So we're also getting 5. Okay. So you can see that the difference between the consecutive numbers is common. So we call this sequence an arithmetic sequence. This one is an arithmetic. This one is an arithmetic sequence. So okay, now we've established the type of sequence that we have. One left for us is to find the general formula. Okay, so what is the general formula for an arithmetic sequence? To find the nth term for an arithmetic sequence, we say the formula is Tn is equal to, let me do like this, Tn is equal to T1 plus n minus 1 d. Okay, so this is general formula for finding the nth term for an arithmetic sequence. The T1 here denotes the first term of the sequence, meaning in our case the first term is negative 11, as you can see here, and D denotes the common difference, the consistent difference, which is 5. Just 5 again, So we have what we're looking for. We're saying T1 is the first term, which is negative 11, and D is our common difference, which is 5, positive 5. So what we're going to do, let me open space here. Now it's a matter of substitution into our formula. We're saying Tn is equal to T1 plus n minus 1 d. Tn is equal to, T1 is the first term, which is negative 11, plus then n minus 1. D is the common difference, which is 5. Then Tn is equal to negative 11. Then now we open bracket, 5 times n, we get plus 5n. Then 5 times negative 1, we get minus 5. Minus 5. Then Tn is equal to 5n. Then minus 11 minus 5, that's minus 16. So our answer here, the general formula is Tn is equal to 5n minus 16. Okay, so we're done with our first question. Then move on to the second question here. This one is a little bit tricky. It's a word problem. Okay, but then it's fine. We're going to use the concept that we know already. Okay, the question says the 15th term and the 11th term of an arithmetic progression are 153 and 109 respectively. Find the first term and the common difference. Okay, this one is a little bit simplified for us because already have told us that this is an arithmetic progression. Okay, so meaning between each consecutive terms, the common difference, the difference is common. Okay. And they're saying, okay, let's break the question down first. They're saying the 15th term is, okay, meaning the 15th term is 153, because they said, they put this thing like respectively. So 15th term correspond to 153 and 11th term correspond to 209. What does this mean? It means term number 15 is equal to 153. Okay, and term number 11 is equal to 109. Okay. So we have these two equations on our hand. But then, because this is an arithmetic sequence, we have to note that if it's an arithmetic sequence, we are using this formula here that which says Tn is equal to T1 plus n minus 1 d. Tn is equal to, okay, I can't write this side. Okay, let me do like this. Okay, let me first calculate this side. Yeah. My bad, my drag is Tn is equal to, oh no, not Tn. We are saying term number 11 is equal to 109. Yeah. Is equal to 109. Okay. And since it's an arithmetic sequence, we know that Tn is equal to T1 plus n minus 1d. Okay. So we have these two equations from the problem that we've just read. So what I'm going to do here is easy. So the question says find the first term and the common difference, meaning they're looking for T1 and D. Okay, so I'm going to find these two terms that they're looking for using the formula that we have here, using the equations that we have. So we're saying term number 15 is equal to 153. Okay, so we're saying now we have Tn is equal to T1 plus n minus 1d. So where there's n, I will put 15 for this first equation. So term number 15 is equal to T1 plus, where there's n, I put 15. So that's 15 minus 1 d. Then T15 is equal to T1 plus 15 minus 1, that's 14. So we get 14d. Okay, and remember that we said T15 here is equal to 153. So T15 is equal to 153. Alright, so we've established our first equation here, which is this one. We're saying T1 plus 14d is equal to 153. So that's our first equation. And in this equation, obviously, we have T1 and D as the unknown values that we're looking for. Okay, let's come to this side. We are saying T11 is equal to 109. And this is our arithmetic formula here. Again, when there's n, I will substitute with 11. So I will say T11 is equal to T1 plus 11 minus 1d. Okay, then T11 is equal to T1 plus 11 minus 1, that's 10D. And recall that we are saying T11 is equal to 109, so T11 is equal to 109. So now we've established our second equation, T1 plus 10D is equal to 109. That's our second equation. Okay, so I think now we can see that the information that they gave us here, this information we've used to establish these two equations here, this one and this one. Okay, so what we're going to do now, because these equations we're only looking for T1 and D, so we're going to use, because this now are asymultaneous equations, we're going to use one of the concepts of solving simultaneous equations to find the T1 and the D. Okay, so I'm going to erase now here, so that I can be able to write our two equations. Okay, so we have T1 plus 14D is equal to 153. That's our first equation, and also we have T1 plus 10D is equal to 209 is our second equation. Okay, so now what we have to do is just to solve these simultaneous equations. Okay, the simplest method to do here, we're going to say that T1, here we have T1, here we have T1, so we can eliminate the T1 by saying equation 1 minus equation 2. So when you do that, we'll say T1 minus T1, we get 0. 14D minus 10D, we get 4D is equal to 153 minus 109. I'm just going to have to use our calculator. Okay, 153 minus 109. That's 4, 4. Okay, that's 44. So we get 44 here. So this one is now an easy equation. 40 is equal to 44. So I have to just divide by 4 both sides. And we get that D is equal to, so T is equal to 11. And then now we're left with finding T1. So finding T1, we'll just use one of the equations here. We can use maybe the second one if we want, which says T1 plus 10D is equal to T1 plus, okay, in order to find T1, we are going to use either of the two equations, but then I've just chosen the second equation, this one. So we're looking for T1, so we're going to say T1 plus, so where's this D? I will substitute with 11, 10, 11 here is equal to 109. Then T1 plus 10 by 11, that's 110, is equal to 109. Then T1 will be equal to 109, then minus 110. T1 would be equal to -1. Okay, so Now we've solved our question. The question was saying find the first term and the common difference. Recall that the first term we denote it by T1, so meaning our first term is the T1 and the common difference is the D. So now we've found what we're looking for. We're saying T1, the first term is -1, and D is equal to 11. D, which is the common difference. Okay. We're done. Then we proceed. Are we done solving this? I think we're not done. Okay, so the question okay, so we'll continue with the other questions because right now I can't be able to see the other questions like B and C. So we'll continue in the next video.